Hi everyone, this is Winfred from NSR Programmers and welcome to our channel. In this video or this tutorial, we shall be deploying Tradesphere-DEX. So I'll give you a step-by-step guide on how to deploy a DEX, and specifically for this video we shall be working with Tradesphere-DEX. To start with, I want to give you a brief introduction on what a DEX is and what Tradesphere is. So, basically a DEX is a decentralized exchange, and it is a cryptocurrency. I can say it is a cryptocurrency trading platform, and this platform operates without a central authority. So, unlike traditional exchanges like Coinbase or Binance, DEXs actually use smart contracts. And when I talk about smart contracts, I mean the self-executing programs on the blockchain. And then these contracts basically facilitate trades directly between the users. So we do not need to depend on companies in order to manage trade. All you need to do with the DEXs is actually to start the trading. So DEXs have importances, and I'll give you a few ones. For example, user control, where you always own your assets, so your funds are not stored in the exchange wallet. Then we have privacy and security. There are less risks of hacks on a central entity. There is global accessibility, in that anyone with the internet and a crypto wallet can trade, so there are no banks needed. Then there is transparency, wide token availability, then censorship resistance, among others. There are lots and lots of importances of using DEXs for exchange or for trading. And specifically, today we shall be looking at Tradesphere-DEX, and Tradesphere-DEX, it is based on the Uniswap version 2 model, and it uses the automated market maker system. So instead of matching buyers and sellers, for it uses liquidity pools. So liquidity pools refers to collections of tokens, and these tokens are locked in smart contracts, and then this enables the trading. So I'm basically going to look at Tradesphere-DEX deployment today, and we shall be deploying it locally, and then using Sepolia Testnet. So we shall not use mainnet for today in today's video, but rather we shall focus on the testnet. So before I go in further, again let me explain more about what mainnet is, what testnet is, what are gas fees, what are private keys, what are smart contracts, this is basically what we shall be talking about into this video. So as I've already said, that we shall be using testnet and not mainnet. Excuse me. So what is a mainnet? So a mainnet, for it is live and production, and it is live and then production blockchain. So where actual real money and real transactions occur. So when we deploy to mainnet, it means we are using a real cryptocurrency, and transactions actually in this deployment cost real money and do not use gas fees, unlike in testnet, as we're going to see. And then it can be disadvantageous in that any mistake is very expensive, or it leads to a lot of losses, because we are dealing with real money, so we can make a simple mistake and then your money is lost. So examples of the mainnet test, we can have Ethereum mainnet, we can have Evmos mainnet, among others. There are so many, over 3,000 plus. Then when we go to Testnet, this is a testing environment, and this testing environment actually mirrors the mainnet, but for it uses fake money. For the benefits, we have free tokens for testing from faucets when using the testnet. Then I can talk about no financial risk, in that we are not putting in any money yet. So the testing and the deployment, it is done just using faucets or tokens from faucets. Then it is actually a safe environment to experiment, to learn from. And the examples I can give, one is being Sepolia Testnet, since it is basically what we are going to actually deal with today. But then there is also Evmos Testnet, and among others. Just know there are so many testnets, like 3,000 plus, because each chain has this. So, and I can say that think of a testnet like a flight simulator. So this flight simulator, it looks real, but you can crash actually without any consequences. So that's how our testnets actually are. Then we have gas fees, and these are transaction costs actually paid to network validators, and they are paid for or to enable processing or the processing of our smart contract deployments and then interactions. Remember, we've talked about the real money and then the fake money. So this is actually referred to as the gas fees. So in the testnet, we have the faucets or the tokens, and this is all gas fees. Then there is some other term that we shall look at as a private key, and a private key basically means I can say a secret key protects your wallet, and it is never actually shared. So with all that being said, let's before I go further, let me also talk about smart contracts. And smart contracts, as I've already explained, they are self-executing programs, and they are found on the blockchain. So our DEX, which is Tradesphere-DEX, consists of 3 main contracts, and we have the factory, the router, and then the pair. So the factory, for it creates new trading pairs basically, and then the router, for it handles swaps and liquidity. The pair contract, for it is actually used for individual trading pools. So as I've already said, we are going to target Sepolia, and Sepolia, it is EVM compatible. So what does this mean? It means it runs Ethereum smart contracts, then there are lower gas fees than Ethereum itself, there are faster transactions, among others. So with Sepolia, and while using testnet, just know we are sorted. So I'll start by letting you know what is actually needed or setting up our development environment. And first, all you need is VS Code, Visual Studio Code, or any other IDE that you're comfortable with. So for my case, I'll be using VS Code. You shall need Node installed on your machine. You need to have npm installed on your machine as well. Then we shall need hard hat and ethers. Sorry, we also need ethers. Yeah, basically that's that. And then before I forget, you also need a MetaMask wallet with the Sepolia network added on to it. So now make sure you have Node.js and npm just to be sure. So when you open your VS Code, you can always install you can always install it. For my case, I already have Node installed, so I'll just check for the version. If you haven't yet installed it, you shall need to do it. No, the term node is not recognized. Okay, so I also do not have Node, so let me first install it, and then I've installed my Node. So if you haven't, you should, and that's my version. And then when I check for the npm version, it shows it is that, and when I check for the hard hat version, it should return the version to ensure that I have it on. Then check for the ethers. It is npm list ethers, so when we run it, it should be able to return the different ethers versions that we are having. So basically, you have to ensure that you have Node, npm, you have hard hat, and then ethers installed on your machine. So why do we need these files? First, wait a bit. Sorry about that. I was saying that we need these files because actually the hard hat it is what we shall use for deployment. For the deployment of our smart contracts. Then the ethers, for them, it is where our the smart contracts shall communicate with our front end, and so they enable that communication. Then the node is for our back end, and then for the front end, we shall need React, or our front end is already in React. So with that being said, I'll take you through the structure, our project structure. So this project, as I've already said, it is actual It has the Uniswap version 2 model, and basically that's that. So this starter kit or project is found on GitHub. You can always just clone it. I'll provide the link from where you can always clone it from. So once you have your project cloned, it will have this structure. And to start with, I'll start from the bottom, and in the bottom I'll talk about first the hard hat .config.js file. So this is our file, and it's actually it's where our blockchain network configurations are put. And for this case, we have about 15 plus networks that we shall be deploying. So the configuration file contains all those, as you can see. Then we have the package.json, and the package.json file, for it has the project dependencies and the deployment scripts. So these are the deployment scripts, all the deployment scripts for our DEX, and then the project dependencies are also kept into this file. So these files are very important, and we shouldn't basically miss them. Another important file to look at is the contracts folder. So when I move into the contracts folder, it has these contracts, as I've already told you. So that the factory.sol, the pair.sol, and then the router.sol. So this is the factory.sol, as I've already said. For it, its major importance is to create and then managing the trading pairs. So this is it. I had already created it. We are using version 0.6.6 because our Uniswap code actually has most of the files written using this Solidity version. Then when I go into the pair.sol, for it has the NVIDIA M pair logic, as I've already said. It does the math, and then that shall be displayed on our front end. Then when I go to the router.sol, this is actually the main interface for swaps and the liquidity stuff that we shall be looking at. They're all done being supported by the router.sol, the Tradesphere router.sol. Then this interfaces folder, for it basically it contains contract interface definitions, as you can see for the now pair.sol contract. Now when we go into the libraries, for it has the mathematical utilities, the math.sol, the safe math, the transfer helper.sol. It is all stored into the libraries folder. Then when we go to our mocks folder, for it has the tester token contracts for development. So the way in this video we shall be dealing with USDT, the USDC, and the ERC2 mock.sol. So this is it with the contracts folder. Now when we go to the front end folder, front end folder, it has a web-based application, and it has a wallet integration where we do the MetaMask, and then the wallet connect, and then the trading interface components. So basically our front end folder has all these, and it is a React application. When we move into the scripts folder, these are some of the most important folders that we shouldn't miss out. Okay, they should be in your new project. So the scripts folder, it has the delpoy.js, and this has multiple network automation. Multiple. I can say I can talk. I'm saying it has it is a multi-network deployment automation. So this is where our deployment actually is automated from. Then which other file that I can take you through we have our verify network.js. For it is for network connectivity sensitivity. Then we have all these are basically for deployment purposes. This is the deployment folder. Basically that's that. Then the test folder, it has this is where we do our tests from. It has content for testing, of files for testing. So let me first the deployment these are just files, then the other file that you shouldn't miss out is the .mv file, as I'm going to show you what it should exactly have. But before I do that, let me first take you through the contracts folder back. Let's first have a recap of it. So the factory this factory file, or this factory contract that you're seeing, this is how actually it works. So when users want to trade let's say token and token B, so the factory creates a new pair. If the contract, it creates a new pair contract if it doesn't exist. This is the factory.sol. Then the pair contract, this pair contract you're seeing here, it holds the liquidity pool, let's say reserves of both tokens, and then it calculates swap rates using the XY equals to K formula, this pair sol. Then the router.sol, or this Tradesphere router contract, for it provides user-friendly functions, for instance like adding liquidity, or becoming this is actually becoming a liquidity provider, removing liquidity, withdrawing your share at any time of your wish, then swapping tokens, and this is basically trading. So the beauty is this, actually when we are dealing with this, all happens actually without human intervention. So it is basically pure mathematics and code that is talking. Now when I go to our .mv file, all you need to have the most important, so I had already done a deployment before on this, so I think that's why you're seeing some of these addresses, but the most important thing that you should have is your private key, and never expose it. I've exposed mine because I created this for just demonstrations. I don't have any intentions of keeping them. Then the testnet, as I've said, we shall use Sepolia. So this, but then the DEX already supports 50 plus, 15 plus 15 plus chains. So for now, I think let me remove this, since we are going to develop again these addresses. This is not important for now, even if you do not have it. So what is important to have right now is the private key, the RPC for Sepolia Testnet. We need to have with address, the Vite EVMOS address, the Vite router address. No, this is still not it is not important. Oh, okay. What we need to have are these three: the private key, and this factory and router address. Yeah, basically that's that we need. So how do we get your private key? How do we get all these? So this router the factory and the router addresses come in after deployment. So I had already done some deployment before. That's why the file had already some content, and we can always get it from this file. So after deployment, we'll see that you get this file, and basically all these files are not supposed, you shall not get them after you clone all these files here, because they automatically come after the compilation and then the deployment. So you shall not always get them. So you shall not have the deployment info.json, the basecamp, the artifacts, the cache. So you shall not have all these. You shall only have the contracts folder, front end, the scripts folder, test folder, the readme package.json, then this desmos.js, and it's basically I used for testing purposes. You can do as many tests as you can write as many test scripts as you wish for this. As you're planning to do your deployment, testing is important if you want to avoid losses. So basically that's that. So before I go any further, let's set up our environment. So as I have already told you, we need MetaMask, and then you need an account connected. So this is where my MetaMask is, and it will prompt me to add a password. In order to connect to it, I shall provide it and unlock it. So this is how the interface looks like. Remember, I've said for this we are using Sepolia-DEX, but at times you may not have Sepolia already added to your network. So all you need to do is come to this menu bar, click on the networks, add custom network. and then put in the required fields. So like the name, it can be the testnet, the Sepolia Testnet. Then you get the RPC URL, you get the chain ID, you get the current symbol, and then the Explorer ID. For my case, I already added this into my network, and this is the information that I actually used. So I come to networks, and let's say search for Sepolia network. It should be there. It is here. I've already added this. So this is the information that you shall put. The network name is Sepolia, then you get the RPC and Sepolia is, and then the Explorer, and then this becomes active, and then you save. For my case, I already have it, so I do not need to put it back. Then after that, you get you go to any faucet, Sepolia faucet, and then you can get actually this is the gas that I was talking about. You can always get it from any provider, for any Sepolia provider faucet or tokens. So I think let me get a link and then show you how you can always get this free Sepolia gas. You can, there's so many providers for Sepolia faucets, so I've managed to come up with this. So all you need to do is come into this and then select Ethereum, Sepolia, or any network that you want, and then you continue. So they'll ask you to provide your private this is your wallet address. So what you need to do is come to your MetaMask, and this is my account, so, and then copy the account. I can first connect it. So you can always copy your account from. Can always copy your wallet address from here for the account that you'll be using, and then you paste it into this site, and then you request for tokens. So you must hold at least one link on Ethereum miner to request for native tokens. So I think it has failed, but it for my first attempt it was successful, and I did it because of I think in the previous 24 hours haven't elapsed yet. So some sites won't give you when you have more than or when you receive the tokens in let's say in less than within 24 hours. You must if you receive tokens, you must wait for 24 hours to elapse before actually you get other tokens. So there are so many sites, so you can always just put in Sepolia faucets, and they'll direct you. And then another way of adding the link, the network to your MetaMask, you can always come to chainlist.org, and you can always add in a network that you want. Let's say this, all you need is connect your wallet, and then you add in the network that you want. I'll not go into that, but you can always add into your network from here instead of manually going to the add custom network. So after you have basically gotten your faucet tokens, or even before, we also need a private key from this. So all you need to do is come into accounts details and request for a private key. You enter your password, and you confirm the password is right. Confirm your password. After confirming your password, you hold, and then the private key will be revealed. You copy it, and then after copying it, then say done. But never share your private key, please. I'm only sharing this for demonstration purposes. You come and put it here in the field for the private key. You see, it's the same because I had already put them here. Then we also need an Testnet RPC for the Sepolia. You need to include it here. The RPC, the test RPC that you used when putting your network, like during the connection. Remember, when you can always get the RPC URL when you come to the networks, and then you say maybe you need Sepolia network, and you come here to edit information. You can always get this is the default RPC, and then you have to paste it into the .mv environment. So now that we have successfully gotten our private key, and then our private key in the .mv file, I think I should now start the real deployment, because we are set to go. You are seeing I have so many RPCs because I have some other networks that are already within, but for now I'm just looking at Sepolia network. And remember, going back into our hardhat.config, I said it so far supports 15 plus networks, and then these networks include the localhost networks with these chain IDs for development, the EVMOS testnet for testing environment with the chain ID 9000. There's so many. The mainnet, and then as you can see, each network has a URL. This is the RPC URL, and the gas price, the chain ID, and then the account. So I mean the private key that shall be gotten from the .mv file. So the beauty of hardhat is we can actually deploy the same contracts on an EVM compatible blockchain with just a network parameter change. So now let's get started into the deployment. So I think I'll need to first clear this, and for our deployment, we have to first run when we run npm run node, this command starts a local hardhat blockchain, and this blockchain runs on a certain Okay, this blockchain runs onto this server. It is available at this server, and then it provides 10 test accounts, and each of these accounts has 10,000 ETH. So you can see there is this private account 01. So it in position 1, this is in position 1 at index 0. So it provides 10 of these. As you can see, our last is at index, so these are 20. That's okay. But remember, each has this 10,000 ETH, and then it resets every time you restart it. So and then it processes transactions immediately or instantly, so there is nothing like waiting. So you can think of it as your personal blockchain laboratory. So in the second command, in another terminal, you leave this where you've deployed from, you leave it running, and then you open another terminal. In this terminal, we shall need first to compile. All you need first to do is to do the compilation, the npx hard hat compile, so that it compiles our solidity files, but mine are already compiled, so there will be nothing to compile. As you can see, it is already done, but there is nothing to compare. But to avoid having a long session, I can use this method where we do it is actually a full automated process. Instead of you running the deploy, the test, you can just npm run dev, and then we say full. So before I run this command, let me take you back to our scripts, the deploy scripts, deploy.js. So this deploy.js, remember I told you it has our deployment scripts. Let me try to look for them. Wait a bit. Okay, what I wanted to show you isn't here, but I will demonstrate it later. Our terminal. So I was talking about this command. It is a one-man army, basically. I can call it that because it executes three things. Actually, when you run this, you don't have to do the compilation. So for it executes three things. One, it deploys the contracts, it creates the mock tokens, and then it sets up liquidity. This command you're seeing here. So when you run it, what will do, it will deploy the Tradesphere factory, it will deploy the Tradesphere router, it will deploy the wait contract, and then it will create mock USDC and then USDT tokens, it will set up initial liquidity pools, and what's the other one, and then it updates the deployment JSON with the addresses. So when we run it, this is actually what I'm talking about. So let me show you what's happening behind the scenes once it is successful. I will show you what's actually what's happening, and you can see it has run successfully. So we have actually successfully done our deployment locally. So let me tell you what's happening actually behind the scenes. So as I open my deploy.js script, or my deploy script, the deploy script detects the network. Like for this case, it is local, so it has detected that the network is it's local network, and actually the local network is this side. Sorry. But it has detected that the network is local first, then it gets the deployer account from our private key. I mean, yes, from the private key that we put in. So this is the network lock. Okay, the network lock is also part of this, where I want to go, but I show you what's really happening. Then after it getting the deploy account from my private key, it will do it will deploy factory with initial setting, with initial fee settings, or with initial setting fees. So after that, it deploys router pointing to factory, and then it saves the addresses for front-end integration. So for the localhost, we deployed a fresh wait contract since there is no wrapped it. So that's actually what's happening behind the scenes. So this is now my deployment .info.json file. So it shows like the network is localhost, and it is at this chain ID, and the deployer address, it gets the gas prices. This is the gas price that we set, then the contract addresses. So now once you get this information, it is this information like the factory and then the router addresses that we shall need to paste into our .env file after the deployment. So these addresses are very crucial because the front end needs them actually to interact with our deployed contracts. I think it makes sense. So let me first copy this and put them back into, this is the factory, into my .env file, factory address, and then the router and the width. I'm putting it into our .env file. And I had already run mine, that's why I had all these. So, but let me just check if it is the same with address. So for the web address, with address. Let me just paste it just to be sure. Yeah, so this is it. Now our everything is set. So let me go back to our terminal. This is actually the output. As you can see, the factory router with, since it's local, and the step 1, it has deployed mock tokens. This is deploying USDC and then USDT. Then the mock tokens deployed are here that we shall need while interacting with our front end. Then we need step 2 is preparing the weight. So our current the current weight balance is 1, then depositing it for weight, and then the final balance was 101.0. Then creating trading pairs, approving tokens for router, then creating weight USDC pair, then with basically with USDC pair created with liquidity. So all this information has been provided, and it is actually the deployment. So there are 2 steps into which we can do this. So this was the automated process. If you're really experienced and you know what you're doing already, that's the step that I encourage you to do or to use before basically actually, but I'll show you another step, another method into which we can do the deployment right now. But now let's set up our development tokens with liquidity. So we can set up, can run npm setup. Sorry, it's in localhost. But this is for the localhost, but we also have to deploy to our Sepolia network using the testnet. So again, it deploys this script, basically deploys the setup. Okay, we've successfully completed the setup. As you can see, again it does the same thing. It gives the factory router with USDC, USDT with pair, then with USDT pair, and the deployment info is again saved to the deployment info.json. So what you need, why do we need this? Actually, since the real tokens do not exist on localhost, we need liquidity for realistic testing, and then it provides immediate trading capabilities. So after all this is being said, after all this is being said, I think before I go to the front end, let's move from our safe-lock environment to the Sepolia Testnet. It is a public testing blockchain. So remember the key differences. For local, there is instant, free, isolated, resets on restart. But then for the testnet, we have real blockchain. It is public, it is permanent, and it uses test tokens. Then for the mainnet, for it we use real money. it is expensive, it is permanent, and then it does to production. So for the testnet, it is what we have done the local. Now let's do the testnet. So testnet gives us the real blockchain experience without actual financial risks. So before deploying to testnet, we need the gas that I was showing you in the beginning of this video, this gas, and I've showed you where we can get it from. There are so many sites actually where you can get this gas from. So once you get that, and then you connect to your MetaMask, and you've ensured that you have Sepolia on your account, we can run our console, or I mean our command for deploying for deploying to Sepolia. So since we had all that set, we can run basically npx hard hat run scripts, deploy JS network Sepolia. So we can run this, and we expect it to do the deployment for the Sepolia network. And if you can see, it shows it is still running, but it is deploying with this account. Remember, this is my account. As you can see, it is 0, it is hex5ed. Once you come to my MetaMask, this is not a good practice, but I'm just doing it just for demonstration. This is the account that it is showing, that it is running onto this account. And when you look at this fees balance, it stays 0.09691, and this is the balance, like it is reading it from the real MetaMask. Then it has deployed to this factory, and then the router is into this, and then the deployment is successful. And then this is the summary of the details. The network is Ethereum Sepolia, the factory is this, the router, and then the addresses are this. So since now we are working with Sepolia, we have to again change our address in the .env environment. So when you come here to the .env environment, you always have to change these. Oh dear, I had also forgotten to put in the token A address and then the token B address, but since we already have them, it is just a paste. So this is 69. This is our factory address. It is what you actually, after every deployment, you have to come and change you have to come and change your .mp5. Then the router address, then the web address has also changed. Then the token A, token B can always be gotten also from this information. Actually, for quick, can always come here and check for it. it's there. So for this, you either choose to use the factory or routers. I mean the USDC or the US. Okay, but for now I shall not put it. I'll put it basically after we are looking onto the front end. So there are so many commands that you can use for deployment, so it depends on which you are comfortable with. So that is that, and I think we should first go into our front end. You can always use this terminal opening another, but I prefer opening another since we shall be so as it loads, what I want to do is as moving into the front end folder, and we see how our front end, how we can integrate this into our front end. But remember, it is the ethers that help us in the communication. So I'm going to move into this folder, the front end folder, audio. Okay, let's use this since it's what is complying. We can first move into our front end folder, seed into front end, and then we npm. So what after installing the dependencies for the back end, and when you move into the front end folder, you also need to install the dependencies for the front end. So you run npm install for the dependencies to be installed, the dependencies for the front end. So after installing the dependencies, I already had them installed. You run npm run dev to run our, this is actually loading our front end onto a localhost. Now once this is done, you open your front end. You can always control and then click onto that, but I have pasted it here, and we see how our front end is looking. So this is our front end. Let me first disconnect my wallet. First disconnect my wallet. So this is how the front end looks. So it has functionalities for creating pair, adding liquidity, and then swapping, making a swap. So the first thing you do is to connect your wallet. Remember, it's a React and Write application. So before, remember, I had disconnected my wallet, so the front end was automatically detecting it. It detected the wallet connection, and then the current network was okay. Let me now do the connection. Wait a bit. Let's stop the server and run again. So now we can connect our wallet. Oh dear. Okay, the wallet connection has some issues.